today we are still looking at elimination. But we're going to sort of wrap up those last odds and end pieces of how we can solve basically all the other problems we don't want to solve with other methods. What happens when nothing just falls into an easy category? Right, when they both say y equals and the numbers are small, solving by graphing is easy. When one of them says y or x equals, substitution is easy. When they're nice and neatly stacked and we see a matching coefficient, elimination is easy. What do we do when we're not in a simple setup? Okay, and usually the answer to that question is that my students prefer to use elimination for those other ones, right? We sort of force your hand. So previously we would force your hand and say, here's how you have to do it with substitution. Here's how you have to do it with graphing, and we would force all the different categories. Okay, I'm not forcing you this time around. I'm telling you, here's the option my students tend to prefer. Elimination tends to be their favorite. It tends to be the simplest solution if the other ones don't work. Okay, so let's say we have something like 2x plus 3y equals 17. And 3x plus 4y equals 24. Okay, we have two equations, we have two variables, so we know we're talking about a system. Okay, solving by graphing isn't an ideal option here because A, our numbers aren't super small, right, 24. B, nothing says y equals. That's going to be a lot of solving to do solving by graphing. Okay, substitution isn't jumping out at us because nothing says x or y equals. We do have the nice, neat, stacked look of elimination, but we don't have a matching number in front. Okay, when we don't have a nice, neat matching number in front, we have to force a matching number in front. Okay, and the way that we do that is with multiplication. Okay, so we are just going to decide. Guys, yes, there are times that one route might be easier than another. Okay, but it's not really easier if it takes you 5 minutes to look at it and consider all the options to decide which one is easiest. Okay, it doesn't really matter. You can use a calculator anyways, so whether or not you're getting the smallest, easiest number isn't really the most important thing. Okay, what's more important is that you get them to match. So you just have to decide, do we want to get rid of x or do we want to get rid of y? Anybody have a preference?
Y.
Y? Okay, so y. Y it is. Why are we picking y? Because George said y. It doesn't really matter. Okay, so we're going to focus here on the y's. That's what we're deciding to get rid of. Okay, whatever coefficient, right? Coefficient is a number in front of a variable. Whatever coefficient is on the bottom, we are going to multiply by on top. Okay, whatever coefficient is on the top, we are going to multiply by on the bottom. Now remember, when we multiply an equation, we can't just multiply in one place. Just like we can't just add two things and like hope for it to be the same thing, right? Our rule has always been whatever we do in one side, we have to do in the other. That multiplication is going to have to happen all the way through the problem. That's why I'm putting the parentheses all the way out here. When we do that, what is 4 times 3? 12. What is 3 times 4? Right, now I'm making them be the same number. Okay, so that takes care of one of the criteria. Right, we said we want them to be the same number and we want them to be the opposite sign. So if I want them to be the opposite sign, now I'm going to check. Is this positive or negative?
Positive.
Positive or negative?
Positive.
Haley, do you have an idea?
You'll put -4.
We're going to make one of them negative. So Haley might decide to make the 4 negative, okay, and I might decide to make the 3 negative. It doesn't matter. This is why I always tell students to be careful when you compare work with a neighbor with systems, okay, because a lot of times you say, well, that's not what I had, so you must be wrong when you could both totally be right, and your work look completely different. Okay, so we're going to make one of them negative. We're making one of them negative because we want the signs to be the opposite sign. Okay, then at this point, I don't care if you pick up a calculator, you just have to multiply it all the way through. Okay, so you'll say -4 times +2 is -8, and you'll keep the variable with it. Then you'll say -4 times +3 is -12y. I know that there's several of you in here who like to write this as like plus a -12y. I'm totally fine with that as well. See, then we'll take -4 times +17, and we'll get -68. Haley, were you just putting that in your calculator?
Yeah.
Was that right? Thanks. Questions on where these 3 numbers came from? Okay, so now I'm going to do that exact same thing with the 3. I'm going to start passing that 3 out. So 3 times 3 is 9. Bringing my x along with it.
So you have to find the least common denominator type of thing?
Kind of, yes. Right, you're finding that least common multiple that you can turn them both into. I just have a problem with saying the least because it doesn't have to be the least. Right? I could have turned these both into 24 and been just fine too. As long as I'm making them the same number. Okay? That's why I say if you just, some of my students just tell me what to do, Mrs. McKinney, and I can do it. Right? If you just take this number on top and this number on bottom, it will always make those numbers match. If you see a smaller number and you want to go that route, by all means you can. You just don't have to.
Is it going to be the same amount of math?
Yes, the exact same amount of math. It doesn't change anything.
Okay.
That's why I'm like, it doesn't really
Matter.
It just doesn't really matter. So let's see, 75, 72. As long as you did, you can just multiply, or just add, sorry. As long as you multiply correctly, you can just add. So then we're exactly back to what we saw in the POD. Now, here is my warning for this. A, if you tend to have messy, unorganized writing, it's easy to get lost in all the work for this. B, if you're the type of student who's like, oh my gosh, this is so much work, I can't do it right, you have mentally convinced yourself you're not going to be able to do it. These have a lot of writing, but not a lot of difficult math. Okay, so even though it looks like there's a lot going on, I mean, right, that was just typing stuff into a calculator and writing down a new equation. Right, we just can't keep all those numbers in our head. Okay, but once we're here, then it's just going straight like we were. So -8 plus 9 is a positive 1x. Our 12s cancel out, right, because we're seeing that positive and negative 12, just like we saw in the POD. -68 plus 72 gives us positive 4. I mean, we can divide by 1, but whatever. This tells us x equals 4.
How would it be positive?
Huh?
How would it be positive?
Why would this be positive?
Yeah.
Because the -68 is the smaller option.
Okay.
Right, so if you had $72 and you spend 68, you would actually have $4 left.
Okay.
Does that make sense?
Yeah.
Okay, we're not done there. We need to take that 4 and we need to plug it back in. Here's where sometimes choice can be a bit overwhelming because we have a lot of places that we could plug this back in. We can plug it in here, we can plug it in here, we can plug it in here, we can plug it in here. I always tell my students it's easier to plug in to the original equation. Those are always going to be the smaller numbers because it will be before you multiply. So anyone have a preference? First green equation or second green equation?
First green.
First, okay. So we're going to take this 4, and we're going to bring it up here, and holy cow, if you just looked at my board, right, you'd be like, what the heck, Mrs. McKinney, there are scribbles everywhere. That's kind of how these problems look. Okay, but let's see, we'd say 2 times 4, which is 8, plus 3y equals 17. Do you see how if you had messy writing, it's already confusing enough with non-messy writing? It gets a little bit ridiculous. 9. Man, I keep picking problems that have the exact same answer. So 3 and 4, but in this case, if we were writing it as an ordered pair, right, we would need the 4 to be first because our x value always goes first. Kind of, sort of, maybe? Hell, let's look at another one. Let's stick to black. Minus 2y equals 10, and 5x plus 3y equals 4. Okay, so we have a decision to make. Graphing isn't going to work. Substitution isn't going to work. This is stacked for elimination. Do we see a variable with a matching number in front? Nope. So we're going to have to multiply. Do we want to get rid of x or do we want to get rid of y? Y, sure. And guys, I have students who are just like, I'm just always going to get rid of y. I'm always going to get rid of y. I'm always going to multiply. Fabulous. It doesn't matter. Okay, it's not like it takes that long to multiply anyways. Okay, so we're going to get rid of y. That means the 3 that was on the bottom is coming up and getting multiplied on the top. The 2 that's on the top is going to the bottom. Notice I didn't bring it down as a -2, right? Because the negative is reserved for if we need to make them the opposite signs. So let's check. Is this y currently positive or negative? Negative. Is this y positive or negative? So those are already opposite signs. So do I want to throw a negative onto one of them? No. So I'm just going to multiply as they are. Okay, so I multiply through on the top. I'll get a 9x minus 6y equals 30. And on the bottom, I will get a 10x plus 6y equals 8. If you're doing a problem, you're like, this just does not seem right, something is going wrong here, usually check your math right here. I mean, I do the same thing, and I've been doing these how many times? Sometimes I'll forget to multiply that last piece. It's an easy mistake to make. So I always tell my students to check there, make sure you multiply it all the way through. Okay, so now we can add. Once we've taken care of that multiplication, we can add. So 9x plus 10x gives us a 19x. Our y's cancel. 30 plus 8 gives us 38. Something we can solve. Are we done with x equals 2? No, what are we gonna do? Plug it back in. Where do we want to plug it back in? To the very top? Sure. Let's pick a new color. So how about, this is my x value, so I'm plugging in for x. So 3 times 2 is 6, minus 2y equals 10. I mean, right, we're just doing the exact same steps over and over. So even though there's several of them, it's the exact same type of two-step equation every time. So we get x equals 2, y equals negative 2, or 2 comma negative 2. We feel okay with those? Okay, then I want to show you one more problem, which is sort of our catch-all for all of those weird problems. Okay, instead of forcing to solve all of them for y and graph or forcing substitution to work, let's say we were given something like, that's what I want. X plus 5y equals 9. And 3x equals 2y plus 4. This is one of the problems in the past that we would look at in every situation, and we would tell you how to do it in every situation. And this is where my students started to hate graphing and hate substitution, because these are really hard to do, graphing and substitution. Okay? The easiest way to go about these sort of weird oddball problems is to make them be elimination. To make them be nice, neat, and stacked. So right now, are these stacked up? No, even if I shifted this over and wrote the x underneath here, would they be stacked? No, right? Because the addition sign would be on top of the equal sign, and that would be bad news. Okay, but we know enough about rearranging equations that we could just use some of our inverse operations to move things where we want them to be. Okay, so if I want this equation to be set up the same way as this equation, and I want my x and y to be on the same side of the equal sign, how do I move a positive 2y? I subtract it, right? I undo a positive with a negative. So if I make this be a negative 2y, and I put that on each side of the equal sign, I can't do anything with 3x minus 2y other than write it as 3x minus 2y. But now I'm all nice and neatly stacked up for elimination. Oh, that's a 4, sorry. I apparently can't read. Okay, and so all that solving that we did last trimester, where we would solve for y, solve for y, solve for y, I mean, you can. Okay, but that's sort of a quick way to say, oh wait, but I could just get them stacked and go through elimination, and well, yeah, I have to do a little bit of multiplying. It's not going to be a whole lot of additional work. Does that make sense? Okay, so here's what I want you to do. I want you to go back to your board markers and erasers.